I'm going to replace that f of negative 4 with that negative 11. And now go to my function g and substitute it in. So 122. All right, so that should be one of each type of problem. And now I will finish working the rest of them. So we'll just go back to the beginning. All right, so let's start with number 2. Number 2, there we go. I am multiplying in between these two. Remember that our large numbers act like they always have. So 4 times a negative 2 is going to be a negative 8. And then I have an n to the 5th times an n squared. Because I am multiplying in between the same base, I add those exponents. So I'm going to get n to the 7th. Okay. Down here in number 4, because I have a power to a power, I'm going to need to take care of that one first. So a squared stays the same. But I have b to the negative 4th being raised to the 3rd. Power to a power tells me I multiply, so I'm going to get b to the negative 12. And then I have c cubed over 4a to the 8th, b to the 4th, and c to the negative 7. All right, so now I'm going to go ahead and reduce my like terms. So I have an a squared and an a to the 8th. Well, since I know that there are more soldiers in the bottom is going to keep the survivors. And once I've eliminated the ones they have in common, I'm left with 6. So an a to the 6th stays in the bottom. Now, I have a b to the negative 12th and a b to the 4th. 4 is larger than negative 12, which means all of these negative 12 soldiers are going to go to the bottom. Because, another way to think of it, remember they're traitors, so they need to go to the opposite side. So I have a b to the 4th already, and if I bring down b to the 12th, I'm going to get b to the 16th. My c's are similar. The only difference is this time the negative is in the bottom. So since it's a traitor, it needs to go to the other side. Well, I already have a c cubed, and if I bring up 7 more, I'm going to end up with c to the 10th. And that becomes my final answer. All right, number 5. We know that anything raised to the 0 power is just 1. This whole second term is being raised to the 0 power. So I really have 5y squared times 1, which is really just 5y squared. Okay? All right, let's go over to the other side and look at number 11. So again, since I'm subtracting in between, I'm going to treat that like a negative 1, and I'm going to distribute. So my first terms don't change, but now I'm going to distribute that negative. And now I'm going to look for like terms. I have a negative 4x squared and a negative 6x squared. So that's going to give me a negative 10x squared. I have a positive 2x and a negative 3x, so a negative x. And then I have a 1 and a 12, so that's going to give me a 13. Okay. Number 12 is just like number 8. So both of these terms have to be distributed to everything in my other set of parentheses. So I have an x cubed times a 4x squared, which is going to give me a 4x to the 5th. And then I have an x cubed times a negative 3x. I'm going to have a negative 3x to the 4th. Then I have an x cubed times a 2. I'm going to get 2x cubed. I have to repeat that for the negative 5x squared. So I have negative 5x squared times 4x squared. So negative 20x to the 4th. Negative 5x squared times a negative 3x. So positive 15x to the 3rd. And I have a negative 5x squared times 2, so negative 10x squared. This is the only one I have that's raised to the 5th, so it's going to come straight down. Now I have a negative 3x to the fourth and a negative 20x to the fourth. That's going to give me a negative 23x to the fourth. Then I have a 2x cubed and a 15x cubed. So I'm going to end up with a 17x cubed. And I have no other squared terms, so minus 10x squared. Okay. Let's flip over to the inside and finish the ones that we have over here. So 14 is, again, long division. So I need to look and say squared, 1, and none. So they're all there, and they're in descending order. Same thing over here. So the n plus 2 is going to go on the outside. And I have n squared minus 8n minus 26. Okay, so I look at my first terms. What would I need to multiply n by to get an n squared? Well, I need one more n, so n. Now I multiply that n to the side. Okay. And I'm going to subtract down. My first terms always go away. I have negative 8n minus 2n. So negative 10n, and I'm going to bring my negative 26 down. What would I need to multiply n by to get a negative 10n? A negative 10. And now I'm going to multiply that through and subtract. First terms always go away. So I have a negative 26 minus a negative 20. So I'm really going to end up adding this 20. So I have negative 6. That becomes my remainder. So my answer is n minus 10 plus a negative 6 over n plus 2. All right. On 16, we are going to use synthetic division again. So I need to make sure it's in descending order and all my powers are there. So 4, 3, 2, 1, nothing. And then I'm dividing by an x plus 2, which means a negative 2 is going to go in my little box. And now I'm going to pull my coefficients. 2, negative 6, and 4. Okay, I'm going to bring my 1 straight down. 1 times negative 2 gives me a negative 2. Add down, so 5 plus a negative 2 gives me a 3. 3 times negative 2 gives me a negative 6, and now I'm going to add down. So negative 4. Negative 4 times negative 2 gives me a positive 8. Add down and I get 2. 2 times negative 2 gives me a negative 4. So this time I get a remainder of 0. Remember that these are the coefficients of my answer. Since the original was raised to the fourth, this one will start off as a third, so cubed. So x cubed plus 3x squared minus 4x plus 2, and plus I got that remainder of 0. Okay. All right, 18 is another composite problem, so I'm going to be plugging g into h and h into g. Let's look at g of h of x first. So instead of writing h of x, I'm going to go ahead and actually replace it with what h of x is equal to. So I'm actually saying g of negative 2x plus 1. Again, anytime I have something in here, all this is telling me to do is replace the x in the function g with the negative 2x plus 1. This time I have a squared, so negative 2x plus 1 squared plus 4. When I have negative 2x plus 1 squared, that actually means I have 2 of these. So negative 2x plus 1, negative 2x plus 1, and then plus the 4. I'm going to have to go ahead and multiply these just like we multiply our polynomials. And then if I have any like terms, combine them. So negative 2x times negative 2x gives me a 4x squared. Negative 2x times 1 gives me a negative 2x. 1 times negative 2x gives me a negative 2x. 1 times 1. And then I still have my plus 4 on the outside. So there's no other squared terms. But I have a negative 2x and a negative 2x. It's going to give me a negative 4x. And I have 1 plus 4. So 5. Now if we go the other way, so I'm going to do h of g of x. So remember, instead of writing g of x right here, I'm going to go ahead and write what g of x actually is. So x squared plus 4. And that's telling me go to my function h, and where there's an x, replace it with x squared plus 4. So instead of writing negative 2x plus 1, I'm going to write negative 2x squared plus 4 plus 1. And then distribute. So negative 2x squared minus 8 plus 1. So negative 2x squared minus 7. Alright, last one, 20. So again, we are plugging in numbers this time instead of just the function. So we will start with f of g of 3. So remember, I start on the inside. So the inside this time is g of 3. So I'm going to go to my function g, and I'm going to replace x with 3. So I get 5 times 3, which is 15, and then minus 1. So g of 3 is actually equal to 14. So I'm going to go back up here, and I'm going to replace this g of 3 with 14. So I end up with f of 14. So I'm going to go to my function f and replace x with a 14. So I end up with 56. Right. Now we're going to do the reverse. So I'm going to do g of f of 3. So I'm going to start on the inside. This time the f of 3 is on the inside. So I'm going to go to my function f, and I'm going to replace x with 3. So 4 times 3 gives me 12, which means that f of 3 is 12. So I'm going to replace this whole statement right there with 12. So now I'm saying g of 12. So let's go to g and replace x with 12. So 5 times 12 is 60, and then minus 1, I get 59. Alright, so that is your review. Make sure that you go back over these so that you are ready for your test next time.